We are taking R.D. Sharma solution. This is class 10 maths, chapter 12, exercise 12.1 of application of trigonometry and height and distances. A tree standing on a horizontal plane. So here is a tree. This is a tree from here to here. Okay, this is a tree standing on a horizontal plane and it is leaning towards east. So it is leaning towards east. It's not straight, it is leaning. So at 2 points situated at a distance of A and B exactly due west. So here is a point, this one. So it is at a distance of A, so this is not A. From here to here it is A. And the second one, this is the point. So there are 2 points at A and B distance. So from here to here it is B. From this point to this point it is B. From this point to this point it is A. From here to here it is A. From here to here it is B. The angles of elevation are alpha and beta. So here it is alpha and here it is beta. Prove that the height of the top of the ground or height from the top of the ground. So this is the tree leaning and this is the height. This is the height we are talking about, h. So this is what h needs to be known. And this has to be this one. We have to prove this. So let us take this as say x from here to here. So I am taking the first triangle, that is this alpha. So I am taking this triangle, So tan alpha will be what? Perpendicular, that is h, by base. So we are taking alpha, so we have to take this one. This is a and this is x, so x plus a. So what do we get? X plus a equal to h by tan alpha. This is our first equation. Now coming to this one, this triangle, bigger triangle, this triangle. So we have beta here. So now taking tan beta now. Tan beta will be perpendicular, that is h by base. Base is what? This is x and this is b. So b plus x. This is b and this is x. So b plus x. What do you get? B plus x equal to h by tan beta. So here in the question it is being asked b minus a. So let us take this one, say second one and the first one. So what we have to do? 2 minus 1 we have to do because we need b minus a. So this b plus x minus x, this a plus x. This is equal to this h by tan beta minus h by tan alpha. This minus this is this minus this. So b plus x minus, this is b plus x minus a minus x. So this goes b minus a. This will be b minus a. And this will be what? Take h as common. What do you get inside? 1 by tan beta minus 1 by tan alpha. So what do you get here? Tan alpha minus tan beta by tan alpha tan beta. This is b minus a. So in order to find h, what we have to do? We have to multiply, this is b minus a. Cross multiply. B minus a with tan alpha tan beta. So what do you get? B minus a tan alpha tan beta. In the denominator it is tan alpha minus tan beta. So tan alpha minus tan beta. This is h and this is what is being sought. So this is what we got. The angle of elevation of a stationary cloud from a point 2500 above a lake is 15 degree. And the angle of depression of its reflection in the lake is 45 degree. So what is the height of the cloud above the lake level? So what we have to do here is, first of all, let us understand that if this is a lake, so this is a lake, then the angle of depression of a stationary cloud from a point which is 2500 above the lake, so this is 2500. Here is a cloud. Now please understand that the reflection will always be at the same distance. So this distance will be same as this distance. This is the only concept in this question. This distance has to be equal to this distance because the reflection will always be, this will be equal to this. So here is the reflection of cloud. The angle of elevation of stationary cloud. So let us make a horizontal. This is the angle of elevation. This is given as 15 degree. This is given as 15 degree. Then we have the other one, which is 45 degree is the depression. 45 degree is the depression angle. So how do we do it? This is depression angle. So this is the depression angle. This is 45 degree. 45 degree. What is the height of the cloud above the lake? So this is 2500. So let us make it as 2500 too. And this is what? This is h. So this is h plus 2500. This is h. This is 2500. So what this will be? This will be 20. This will be h plus 2500. Because this length from here to here has to be equal to this to this. That is the main concern. Okay. Now coming to the triangles. First I'll take this triangle. Let us assume that the distance between them is x. So first I'm taking this triangle. Triangle PCQ. So PCQ, what do we get? We get tan 15 degree equal to this perpendicular by base. So h by x. H by x. So let it be here. Tan 45 degree, 15 degree will be what? So I will take 15 and take the tan of it. So it will be tan. We have to take the tan of this. So let it be here. I'll just go to the second one. Then I will take the actual values. So now I'm coming to this triangle. Triangle PQC. This triangle. PQC. So what do we get? Tan 45 is equal to this. Tan 45 will be perpendicular by base. Perpendicular by base. Perpendicular is what? This is 2500. This is 2500 plus h. So it will be 2500 plus 2500 plus h. Perpendicular by base. What is base? X. This is base. X. So tan 45 degree is 1. So we can just say x will be equal to 2500 plus 2500 is 5000. 5000 plus h. This is our first equation. This is our second equation. First equation was first I have to find tan 15 degree. The tan 15 degree will be what? It is h will be equal to this will be 0.2679. This will be 10 15 degrees 0.2679, and this will be x. H will be this one. So in order to find the x, because we have to eliminate x, so x will be equal to h by 0.2679, right? So let us take 1 by x of this. So we get 0. This will be 1 by x will be 3.73. So this will be x will be equal to 3.73 h. I am putting it here. X is 3.73 h equal to 5000 plus h. I hope you got the idea. X is h by this one. So I took this as inversion, that is 1 by 0.26. It is 3.7. Now bring it here. This will be 3.73 h minus h equal to 5000. So this will be equal to 3.73 minus 1. So it will be 2.73 h equal to 5000. So what will be h? 5000 by 2.73. So I'm just computing it. It is 5000 and divided by, we have 2.73. 2.73, and this is going to be 1831. This is going to be 1831 meter. So h is what? 1831. And what is the height above the height of the cloud above the lake level? It is h plus 2500. This h we have computed, we have to add 2500. Just add 2500. What do we get? We add 2500. So what do we get? We get this as 1, 3, and this is again 3, and this is 2, 3, 4. So 4331.50. This is your answer. This is the height of the cloud above this lake level. If the angle of elevation of a cloud from a point h meter above a lake is alpha, and the angle of depression of its reflection in the lake is beta, prove that the distance of the cloud from the point of observation is 2h sec alpha by tan beta minus tan alpha. So what we are going to do here is, see, first of all, the angle of elevation is given as alpha, the angle of depression is given as beta, and we'll assume this height, it is given as h, right? This h is given, so this will also be h, so we take it as x now from here to here. So as with the previous logic, the reflection will be exactly equal to this one, so this from here to here it will be h plus x. It seems to be by diagram that it is less, but it is not. It has to be equal to h plus x. Just to make a diagram a little smaller, we have done this. So h plus x is this one, this is h plus x. So let us take this as x, sorry, y, from here to here. This will also be y from here to here. What is now tan alpha? Tan alpha. Tan alpha will be what? Tan alpha will be x by y. This is our first equation. Now coming to tan beta. Tan beta will be what? It will be h plus x, h plus x, that is this one and this one. So this is a whole one. It will be h plus x by y. So y from here, what do you get? Y equal to x by tan alpha. From here, what do you get? Y equal to h plus s, h is 2h plus x by 2h plus x by tan beta. So this is first, this is second. So this is first and this is second. Now equate them because both are y. So x by tan alpha equal to 2h plus x by tan beta. This is what you get, right? So in order to get this x, let me take these separately. That is, this will be 2h by tan beta minus x by plus x by tan beta. Now I'm taking this one. I wrote this as this one. Now I'm taking this x here. So it will be x by tan alpha minus x by tan beta equal to 2h by tan beta. So here let me take x as common. X as common. So you get, prove that the distance of the cloud from the point of observation. So this is, I have to eliminate x. So I have to get 2h because this is the, prove the distance of the cloud from the point of observation. Okay, now we have to find this one, right? So now let me take, because this distance has to be found out. So here we have this one, say I am taking it as some k, right? So what this shows, this is our k, this is our hypotenuse, and this is our base. This is our base. So hypotenuse by base. So I'm taking cos alpha here is base upon hypotenuse, that is y upon hypotenuse, that is k. So k we have to find out. So k can be written as what? K can be written as y by cos alpha, that is y sec alpha. Y sec alpha. So what I'm trying to do here is, see, y is sec alpha. Y is sec alpha. So I'll put y as sec alpha here, and I will eliminate the x. So here I'll put this as k, this is k as y sec alpha. So I'm going to put y as k is cos alpha, sorry. Y as k cos alpha. So I'm putting it as y as k cos alpha equal to x by tan alpha. In this equation, I'm not going to do this. And in this equation, what I'm going to do, y equal to 2h plus x by tan beta. So y can be written as k cos alpha. Again, this is 2h plus x by tan beta. Okay. Now, what we need this k. We need this k. This is cos alpha and this is cos alpha. We need this k. So in order to get this k, we need to eliminate the x. So what is this showing? This will be showing x equal to k cos alpha tan alpha. And what this is going to give us? X will be equal to, say, k cos alpha into tan beta. K cos alpha into tan beta. And then we have this multiplied, and now we have to take 2h also here. 2h also here, so it will be minus 2h. Now we have to equate these two because x, now we have to equate this. So we have k cos alpha tan alpha equal to k cos alpha tan beta minus 2h. Okay, now I have to find out this k. So I'm bringing this k here and taking this 2h here. 2h will be equal to, this is k cos beta, cos alpha, k cos alpha, and this is tan beta, and here I'm bringing it, so I'm taking this k as common. So we have cos alpha tan beta, and here we have cos alpha and tan alpha. So I can take this cos alpha also common. So this will be, let me do it here. So 2h will be equal to k, this is k, cos alpha also I'm taking outside, cos alpha, this is tan beta minus tan alpha. So in order to get this k, what are we going to do? We are taking everything on the down. So this k will be equal to 2h by cos alpha. So cos alpha, when it goes there, I can write it as sec alpha. So this will be sec alpha. I'm taking it up on the numerator. Cos alpha, I'm taking it up. What is the denominator? It is tan beta minus tan alpha. This is the answer, and this is what is being asked. 2h sec alpha by tan beta minus tan alpha. So the first thing which I did, it was just a trial, but this steps, because I actually came to know when I did this that okay, we have to find this one. So I just changed my track. This is how we have to do it. From an airplane vertically above a straight horizontal road, the angle of depression of two consecutive milestones are opposite on the opposite side of the airplane are observed to be alpha and beta. Show that the height in miles of aeroplane above the road is given by this number. So here we have this aeroplane. Here we have two points, and these are 1 mile apart because they are showing the consecutive milestones. So from here to here, the distance between them are 1 mile. So if I take this as x, this will be 1 minus x. I'm taking this distance as x, so it will be 1 minus x. So this is alpha, this is beta, this is the aeroplane. So let us take this triangle first. So tan alpha will be equal to what? It will be, tan alpha will be equal to h by x. And here second one we are taking, tan beta will be equal to h by 1 minus x. Now we have to find out h, so we have to eliminate the x1. So x can be written as h by tan alpha here. Here I can write tan beta into 1 minus x equal to h. In place of x, I am putting now h by tan alpha. So this will be tan beta 1 minus h by tan alpha. 1 minus h by tan alpha equal to h. This will be tan beta minus h tan beta by tan alpha equal to h. But here we have h, so I have to bring it here. Tan beta equal to h plus h tan beta by tan alpha. H I am taking common, so this will be 1 plus tan beta by tan alpha. So this is going to be tan alpha plus tan beta. It is tan alpha plus tan beta by tan alpha. But we have tan beta here, so I am cross multiplying. This is tan beta tan alpha. So tan beta tan alpha will be equal to h. This is tan alpha plus tan beta, so I am putting it here. Tan alpha plus tan beta. This is h, and this is what we have to find out. This is the answer. PQ is a post given height a, so this is a post of height a meter, and AB is a tower. So this is a tower at some distance. If alpha and beta, this is alpha and this is beta, are the angle of elevation of B from the top of the tower, and P and Q this respectively. So P is having alpha as the angle of elevation, you can say, and angle of elevation from Q is this beta. Find the height of the tower and the distance between the posts. So the height of the tower, this will be A, this will be H. Let us assume it to be H. So this is X. So let us take this one, first one, that is this triangle I'm taking, this triangle. So tan beta will be equal to H by X. Coming to this triangle, this will be tan alpha, it is going to be H plus A by X. So in order to find say X, because we have to find out the height of the tower and distance also, X and H both have to be found out. So let us say that H is X tan beta, and I'm putting X here. This will be X tan alpha equal to H is X tan beta plus A. So I'm taking it here now. X, I'm taking common, so tan alpha minus tan beta. This I took, X I took common, so tan alpha minus tan beta equal to A. So X will be equal to A by tan alpha minus tan beta. So this is your X, this is your X, A by tan alpha minus tan beta, that is the distance between them. And now coming to the H one, so H is X tan beta. So H will be equal to this A by tan alpha minus tan beta into this tan beta. So A tan beta by tan alpha minus tan beta, so A tan beta, this is beta. A tan beta by tan alpha minus tan beta is the answer of this height. A ladder rests against a wall at an angle of alpha to the horizontal. So there is a ladder here. It is making an angle of alpha to the horizontal. If its foot is put away from the wall, so its foot is put away or pulled away from the wall through a distance A, so that it slides a distance B down the wall. So now when it is pushed A, this B, it comes down B. That means you have this one, a ladder. Now it is pushed down, so it will go like this. This is A and this is B. This is angle alpha and this is angle beta. Show that A by B is cos alpha minus cos beta by sin of beta minus sin alpha. So first of all, what we are going to do, see, we'll try to find out sin alpha here. Sin alpha. Let us take this as X and this is Y. This is X and this is Y. So what will be tan alpha? Tan alpha will be perpendicular by base. So tan alpha will be equal to B plus Y by X. This is our first equation. Coming to tan beta. Oh no, we don't have to take tan. See, because we have a height. It is given in the question, right? We have a height, so we can just take it as H and then we can try to eliminate it. Because A and B are given, H can be eliminated. So let us see what we do. We'll try to find out the sin alpha. Sin alpha is what? Perpendicular upon hypotenuse. So this is perpendicular, B plus Y, this is B plus Y upon hypotenuse, that is H. This is sin alpha. What is cos alpha? Base upon hypotenuse. For same thing. Base is X, hypotenuse is H. This is first one. Coming to second triangle. What is the sin beta? See, this triangle I'm taking. Sin beta is perpendicular upon hypotenuse. Perpendicular is this Y, only Y, by hypotenuse, that is H. This remains as H here also. And what is cos beta? It is going to be base upon hypotenuse. So what is the base? Base is A plus X by hypotenuse, that is H. Okay. Now let us take sin alpha minus, that is, this is 1, this is 2, this is 3 and this is 4. So I'm taking 1 minus 3. So 1 minus 3 I'm taking. So sin alpha minus sin beta will be what? B plus Y, that is B by H plus Y by H. This can be written as B by H plus Y by H minus this Y by H. This gets cancelled. It will be B by H. It will be B by H. So sin alpha minus sin beta is B by H. B by H. Now coming to this one. Now I'm doing this 4 minus 2. 4 minus 2 I'm doing. So 4 minus 2 is this cos beta minus cos alpha. This is going to be equal to a plus x by h. I can write it as a by h plus x by h minus x by h. See, this gets cancelled. So it will be a by h. Cos beta minus cos alpha equal to a by h. Now, this is say 5 and this is 6. So what I'm going to do is, I'm going to divide these two. That is 6 by 5 I'm going to do. So this is cos beta minus cos alpha by sin alpha minus sin beta. That is this one divided by this one. And this is going to be a by h equal to a by h by b by h. So a by h by b by h. H gets cancelled, it will be a by b. And this is exactly what we wanted. This is what is this. So this is cos beta minus cos alpha by sin beta minus sin alpha equal to a by b. A tower subtends an angle alpha at a point A. So what we're going to do is we are going to take this question in the next discussion. Okay. So till then, thank you so much. Take care of yourself.